A very warm welcome to our team of experts here in front of the audience. So we have Liliana Ivanova from Zattoo. Now it starts getting complicated. And then we have Dominic Fosters from Scalestream.
Yeah.
And Anders Nassmann from Akamai Technologies. And a special thank to Akamai and Scalestream for co-sponsoring this breakfast here. So thank you for that. Some of the food is coming from Akamai and from Scalestream. So
Every second bite.
yeah.
Enjoy.
Yeah, and I'd like to start with a quick introduction around what you are doing. So for people who are not that familiar with your company. So, Liana, would you like to start?
Yeah, so Zattoo is a company that does TV over internet. We started with a pure D2C business known as Zattoo, where you could watch TV in Switzerland and Germany, download an app. The initial one was just a web thingy on a Microsoft computer that was really crappy. Nowadays you can download the app on any mobile device, any smart TV, basically anything that can play video. And since 8-9 years, we are very heavily also in the B2B business, where we do white label hosted solution for operators who want to outsource their TV, and we do it for them, for different companies. We also have a streaming API business that is for companies who want to do everything besides the front-end apps, who don't want to do everything besides the front-end, so we do the back-end for them. We specialize really heavily in the video back-end services and the streaming part.
Yeah, thank you. And our companies don't have a business relationship. It's just that I'm using Zattoo since 2 years now as our exclusive TV set. So thank you for that service. Yeah. Okay, Dominic.
Good. Scalestream, it's a software-based company in Stockholm. We mainly provide solutions for streaming. Everything started in 2017 with an Origin repackaging solution. Later on, we built CDN. Add-ons, lately also transcoding offline, just-in-time transcoding, live transcoding. So we mainly enable streaming for broadcasters, tier 1 telcos, and event-based streaming, whatever you need.
Great.
Yeah, and Akamai, probably fairly known, but we originally started as a CDN company. I shouldn't say we left that business. We are definitely in that business. We're by far the largest CDN globally deployed. What we've been doing recently is to add the ability to run your own compute on that platform. So we both have like a cloud and a edge compute offering. And then what I feel is very little known in the media industry is that we're also doing a lot of security. So a lot of our income today comes from security. And that's also important for companies like yourselves. You know, you need to think about how your logins are handled. You need to think about content scraping that pirates are doing and all those kind of things. So there's a really, really important aspect of security that when it comes to media as well. So yes, edge delivery, compute, and security.
How do we work with cloud? How do we work with on-prem? What is that from our perspective? And what value does it bring to the services that we do? And how do we choose which portion of our workloads we put on either side? You know, that's where we would like to start. So let's start from the left with a small startup here. So Zattoo, what's your pick currently on choosing cloud services or doing things on-prem? How are you positioned there?
Yeah, so at the moment we are heavily on-prem. There is multiple reasons for that. So one of that is historical, like 11, 12 years ago when we started, this was kind of the only solution for what we were doing. Everything else was very hard to get to and to deploy and to use. We already had that built, so with the time we just continued using it. But we evaluate every year more or less like the cost. How is it on-prem versus cloud? And since we are kind of the cloud for our business customers, we still need to keep the costs as low as possible for them. So on-prem makes more sense for us. And we try, so what we are always trying to do, like our core services like video processing and coding and all of that, that stays in-house because that needs a lot of compute power that otherwise costs us. We have 1,700 channels at the moment on the platform, which we encode 24/7. And storage is also like a big thing that has constant reads and writes, so downloads and like also uploads. That also evaluation-wise never worked to be in the cloud, so we only experiment in the cloud. We say testing new technologies definitely makes sense to do it in the cloud. If we go on markets outside of Europe where we have nothing, we'll definitely launch cloud. I don't know, in the future we'll evaluate what makes sense, but I think it's a very thin border between on cloud and prem, what makes sense for you and what doesn't. For us at the moment, in Europe, when we already have everything, makes sense to stay in cloud.
On-prem.
On-prem,
okay.
on-prem, yes. On-prem, yes.
We will get that much more.
On-prem, yeah.
And on-prem in Europe, what does that mean in terms of location or numbers of data centers? So what is on-prem for you then?
Yeah, so we have multiple locations in Zurich and Frankfurt, and we have the wind course in Paderborn, which is a special location for us. It's a data center inside wind turbines. So very special. We use it specifically for video encoding and transcoding because it gets the electricity directly from the wind. So multiple racks in all those locations where we have fully redundant network backbone built between them with combination of fibers or wavelengths rented through different operators. We don't own them, right? So we rent them from other companies. And we just split everything, like middleware, video, or like CDN would be in all of those locations for redundancy purposes.
So that means mainly Switzerland and Frankfurt, and then a specific use case in Paderborn for video encoding,
Correct.
which is remotely connected to Frankfurt potentially, or do they?
To both Frankfurt and Zurich. So
like a
all
small
of our
ring.
data centers have like at least 2 connections to 2 of the others, like full mesh. And we also have like very small like presences in Vienna and Paris and other cities where we only ingest channels. Because nowadays most of the channels are also moving to IP. We have headends, so we have also the satellite and the DVB-T setup. That's in Zurich and in Paderborn, also for redundancy.
Okay, so not a lot of mountains in Paderborn and no trees.
No. No.
Okay, good. Okay, thank you. Dominic, on your side, you're developing software, so why do you need to care about cloud versus on-prem at all?
So on our case, our software, it's fully microservice architecture, so we don't really force our customers into one direction, cloud or on-prem. We more or less enable what they can do. So our software can run on-prem, it can run in the cloud, it can run hybrid. What we do see is heavy-duty processes like transcoding, packaging is often still in the cloud, especially on the tier 1 telcos. Although there's a clear shift that we see in latest requirements, RFPs, that there needs to be either a hybrid solution or even fully cloud in some cases. So we clearly do see the shift coming, that customers are moving into cloud. For us, we enable it. We don't really force them. Although in the cloud enables us to handle different use cases like we did before. Initially, tier 1 operators, broadcasters were our customers. But with the cloud, and especially with Akamai and the VPU cards from NetInt in the cloud, this enables us to handle different use cases like hospitality, event-based streaming, so different use cases that we can easily spin up in the cloud. And then especially on that part, cloud is important if you need to spin it up in a matter of days instead of months or weeks. This is definitely in favor of the cloud. So it reduces complexity, it increases the spin-up time and so on. So for us, it's a bit of a mix. We have customers running on-prem, in the cloud, hybrid. So it's a bit of a combination.
And just for those who don't know NetInt, the company that you mentioned, so if you do transcoding, you usually can do it in CPU or with a GPU, NVIDIA graphics card, or there is a category of cards that is called VPUs by NetInt, which are ASICs that are built to accelerate encoding with hardware.
Yeah.
And those are traditionally available on-prem, but now also
Yeah.
in a cloud provider. No? So I think you said that the tier one providers are working mostly still on cloud, but you meant on-prem, I think. No? They are
Yeah.
still on-prem, no?
At the moment, it's
it's
mainly
more-
on-prem, but in the latest RFPs, we see a shift that at least there needs to be a cloud enablement option.
And for you to enable that your software can run both on-prem and in the cloud, what did you do in terms of software architecture? So what decisions did you make to make sure that it can run in different cloud provider or in the cloud? And what does that mean to you? Is that automatically ready to be run in all cloud providers, or is there an adoption to each? What was the process there?
The platform from the beginning in 2017 was developed with 3 things in mind. Performance. We can handle quite a lot of channels on one rack unit. At that time, it was fully on-prem. Of course, the same resource benefits are still relevant in the cloud. The second one was ease of use, and then the third one was flexibility. And then this really ties into the cloud because we have different microservices. So every function, like live, like packaging, like DRM, fault, everything is a microservice, and then we can just deploy these microservices where we need. We can deploy it as a systemd on the server for heavy duty. We can also deploy it as a Docker container or in Kubernetes. So we're quite agnostic to where it can run. So we can deploy specific functions, as we call it, on-prem. Some functions that make sense to run in the cloud, we can just move them to the cloud. And for us, it's not really a concept of hardware versus cloud. It's more a microservice that we deploy where we need it. So in that sense, it's quite plug and play. And if it's on-prem, if it's different cloud providers, for us it's all the same.
Okay. And with microservices, you do not only mean Kubernetes. It's a mixture. You can adopt to different environments then. No? And is there something that you needed to take care about that? So is that because I understand from a lot of people who are working with Kubernetes that it's quite a complex, or can be quite a complex beast. Was that part of the decision to not require Kubernetes, but also require or work with some of the more lightweight containerization?
We wanted to be as agnostic as possible for whatever you want to deploy it on. So we didn't really push into Kubernetes as such. It's an enabler for us if customers need it. We have one customer running everything fully in Kubernetes. As you mentioned, of course, there's a whole management around it that comes with it. That could make it complex. On the other end, there are also some benefits like auto scaling and so on.
Okay. Yeah, thank you. Anders, so cloud.
Should I defend cloud now?
Not necessarily, because you had a journey. I think Akamai has been using cloud services from others for a very long time at a very high bill. So perhaps can you start there somehow?
Yeah, I can start there. So yes, our core services has always been delivered on our own hardware, placed in different ISPs. So the guys down here have a lot of servers in their networks. All those servers and all the data that goes through it creates a lot of logs, a lot of metadata, a lot of information. And a lot of that was offloaded into clouds because it has varying sizes and it really didn't scale doing it on our platform. And we didn't own any data centers either. Akamai hasn't owned data center until just recently. And a few years back, rightfully as you said, we took the decision that, hey, we cannot offload this to others. There are a number of reasons for that. It could be economical, but it's also how we treat data and how we want to partition data for ourselves and for our customers. So we acquired a cloud compute company. That said, we've been running a lot of, should we say, cloud workloads on our edge platform, so the CDN platform, for a long, long time. We call them cloudlets, and it was even before the cloud was even invented. So we've been running these kind of workloads for quite some time. And also back to the concept of cloud, we tend not to call it cloud. It kind of itches a little bit. And we want to kind of lean into edge instead. What our customers goes to us for is, edge security, edge delivery, and also edge compute. So we want to be close to where the end users are. And that's not very simple if you want to build a global service. That's where we are coming from. We're trying to, bring compute to the delivery on the global scale that we've been running for a long time in Akamai.
And then you acquired Linode, which we had actually been using before it was acquired, so we
Me
knew.
too.
So we knew that as a very sleeves up, practical, pragmatic cloud provider without all the bells and whistles of the larger ones, but at the same time easier to understand. No? So that was a different approach to this kind of let me rent compute somewhere else in some other location. No? And now, step forward, you're both using your own connected edge compute services for your own services, where you practically operate your own code on it, sell that as a product, and are selling the services or the infrastructure to customers. No?
Yeah.
So how does that work, like that dog fooding, where you try to use your own infrastructure?
It was more of a bumpy ride from the start. Linode, and you need to know a little bit about the background to this, and I think that's where we are coming from as well. I ran my kids' gaming servers on Linode. That's where I came from. And it's like, oh, we bought Linode. This is fun. I already know this system. It's I should say it was bumpy from the start. Coming from Linode was very much sponsoring, startup community, small independent developers, and we wanted to bring it to enterprise. So that's, taking something very, very small and maybe a bit shaky even, I should say, and bring it to the enterprise scale that we use in Akamai generally. I think we're ready, and we see that when we get a lot of enterprise compute to the platform now. So it's been a 3-year journey now, but I think we're there. So
and that must be a balance in itself to cater both for those who knew Linode before the acquisition.
They're still there.
No, yeah,
It's
they're
like
still there, and then the
49,000
enterprise
of them.
customers with SLA demands and everything else. No?
Yeah, and those are both technical challenges and legal business challenges, because we have a pricing that is also set to the expectation that the small developers have, and then all of a sudden you have enterprise demands on that, and that is challenging.
I guess so.
But interesting.
Of course, yeah, of course. So we received a couple of upfront questions actually from people who are perhaps joining today or didn't make it today, but I'm still have the questions here, so they might lead us through this discussion here a bit. So one of the questions was that what is driving companies towards the cloud? What's holding them back? So you said you see, Dominic, you see that there is a shift in that tenders now demand cloud. Some are working hybrid. So what is the appeal of cloud and what is it not? So let's start again here a bit and let's have a lovely discussion here. So what holds you back off using the cloud? As you said, mostly it's on-prem right now. What is it specifically?
Yeah, so for us it's mainly the cost, and also we already have the built infrastructure. That's a big thing. I think if we now need to start building it from scratch, it might be different because it's not so easy, right? But we already just extend it. We also host Kubernetes in-house, so we can do all of that stuff. But I think that people how they are deciding, it's based on what kind of employees you have. Can you really cater for the on-prem? It's difficult to make it redundant. It's much more, many more teams that you need to have to be able to cater for that. And on cloud, it's easy. You just click and it's there. Someone else takes care of the redundancy. Someone else takes care of the old server that needs to be replaced, but it comes at a cost. So you need to evaluate which one is the right for you. What I've also noticed is a lot of the newer developers, they tend to only work with cloud. They hear cloud, and that's why cloud. That's what we want to work with. What's that on premise? We don't know that. It's
But
difficult.
Viljana, I think you should say to them that, hey, we are operating our own cloud. Because
Yeah,
really
at the
that's
end,
what you're doing,
at
right?
the end, that's what we do at the moment.
Yeah.
Yes. So it wasn't maybe 5 years ago. It was different. Like our developers were also very heavily involved, like into the infrastructure, and now we're trying to really do it that the developers have their own cloud. But as I said, we are also operating the cloud for our business customers, right? So we cannot resell the cloud of someone else as another cloud service. So I think it really depends on the kind of services that we have, from my point of
Yeah,
view.
and that's true for Arcam as well. Now, if it's the cloud for us, but for you, it's on-prem. No?
Yeah.
You have complete control
Yeah.
then, and you're still open to use cloud of somebody else if there is a need.
Yeah, and if
mix and
there's
match, no?
special functions that are really useful there, we will use it. And or if there are legal boundaries or anything else that we need to cater for. So yes.
Yeah, it's the same for us. So as I said, like if we go in a new market, most probably we will do the first deployment in a cloud. I mean, it doesn't make sense when we don't know if the business is going to grow or not to build everything from scratch and then decide.
So unforeseeable future, you don't
Yeah.
know how long you will need these resources.
Yeah, exactly. Well, what I also think is maybe like offloading peaks where you can is a good opportunity for cloud, where you just randomly use it when you need it. Saves you a lot of trouble to having everything triple or quadruple even for like Euro Cups and World Cups. We don't do it at the moment, but it's definitely on our radar to do it. We have data pipelines also in the cloud, which is not our specialty, so makes our lives easier. So we're not totally against that. We just always evaluate, and that's what I think all the companies need to do. Like keep core maybe on-prem, and then have like the flexibility of everything else in the cloud.
Yeah, we also see it at some operators that pop-up channels, for example, they are spinned up in the cloud. Because the on-prem it's designed for the main traffic or the main channels, and then pop-up channels like Olympic Games or football, or these are spinned up in the cloud because these are one-time events or short events, and then they spin it up in the cloud, and afterwards they tear it down again. So it adds a lot of flexibility on spinning it up fast and just not keeping it running forever. So it's a bit of a combination of either it's cost. Flexibility to spin it up fast, and sometimes it's also a business decision, because what we also see more is that some companies are outsourcing more and more again, that they want to focus on the core business and not messing around with data centers and having people going to the data center, replace disks. So it's more of a business decision, like we want to focus on our core, and we leave it to somebody else. So
I think Viljana, you also mentioned it a little bit about legacy, because I talked to Andreas Hayden at Dyn just the other week, and they had the luxury in 2023 of starting the journey in the cloud, so they built everything cloud from the start. I'm also working with another customer, I can't really mention, but they have the legacy. They've been building TV houses. They have all the infrastructure, both network-wise, but also cabling, just miles and miles of cabling. And now they're moving facility, and they taken the decision that okay, we're going to restart completely, and we're going to do all cloud. So they're going the kind of Dyn way in that sense. But I definitely agree that there are workloads that fits very well locally, like a 24/7 live stream. It needs to come from somewhere. It's produced somewhere. It's coming from a camera, right? So yes, you can get IP from the camera, but it kind of makes sense doing some kind of production. Again, back to the Dyn example, they are doing all the production with tools built in the cloud, so they're doing all the graphics overlays and everything there as well. So it can clearly be done, but there's still some cabling on the arena, there's still some cameras, and there's still an encoder sitting there doing stuff. So
And moving all these source signals in a very high quality into the cloud is a huge effort, and requires big bandwidth pipes. No? So that also feels at times a bit odd to push all that signals into the cloud to just work on them there and not just work with the reduced amount of work that you have after encoding, perhaps? No? Okay, but there is a pattern that if you have, you don't know what the load is, you have a region where you don't have infrastructure, those are things where you want to experiment in a lab environment and you don't know how long you will need that, and peaks is obviously a good choice. No? So I think part of our questions was how you blend cloud and on-prem, especially for event streaming, and I think on a broader scale, we talked about, Dominic, what you did with your software to create it in a way that is based on microservices so that you can easily use it on different environments. I think, Jana, you also said that your software you are using Kubernetes, so in theory you could move workloads to the cloud pretty easy. But I like to understand what we need to do to being able and to keep open to the possibility to move between these different locations. So is Kubernetes, a lot of thoughts here, just let's try to focus that. Is Kubernetes your backbone of your service, or is this just used for a certain amount of workloads?
No, it's currently used only for certain amounts of workloads. Like, for example, the video encoding, transcoding that doesn't run on Kubernetes. We have still the middleware on Docker, but is planned to be migrated to Kubernetes. So it's a mixture. We started exploring building Kubernetes in-house like 4 or 5 years ago because we did not have the experience. We knew it's a heavy journey, which it is, I can confirm. So we at the moment have maybe 50% of our services running on Kubernetes, but the rest is also Docker, so it's super easy to deploy in cloud if it's needed, or on just virtual servers if you need to do that. So everything is designed in a way. We also run microservices, so everything is like broken down as much as possible. And if tomorrow we need to deploy in the cloud, we can with less effort do it with a little effort.
Okay, thank you. Yeah, what we experienced ourselves when we moved workloads from other cloud providers to the Akamai Connected Cloud was that there weren't all of these specialized services that you are used to if you work with one of the hyperscalers. No? And I was a victim to that myself, so I have a AWS solution architect exam, and I was deeply into that, and we also work with Azure. And you can really get lost in that ecosystem and in that environment, and with all those exams parties in Las Vegas, you get pretty branded if you are in that universe. And pulling yourself out of that is as difficult as not using Apple devices anymore or something like that. So it's difficult. With Linode, there were less proprietary tools, none at all practically. There were some managed Kubernetes that we work with, but otherwise it was pretty bare bones. And what we experienced that in the discussions that we had, and we are perhaps privileged in a way because we have been working with Akamai for such a long time, that we got access to a lot of the right people inside the new Linode compute world, where we got a lot of very valuable tips what we should do, what we should use. So a lot of the technology that Linode has been recommended to say, we said, hey, we have that service on AWS. What's the equivalent on Linode? And Linode said, no, we don't have that equivalent, but there is an open source tool that should exactly do the job, and we're using it internally. And so a couple of these services we integrated into our workflow. And so Linode educated us to transform our own software development in a way that allowed us to run it not only on Linode, but on other cloud providers as well, without the lock-in, and at the same time enabled us to use that same framework on-prem. So we are using Kubernetes, yes, not for all workloads, but for a lot of them, but with a lot of the tools that the Linode team recommended to us. So that was a good journey for us, because we're now in a position where we can pretty freely move between the clouds and on-prem. And that is the first step you have to do if you want to have that decision at all. No?
I think an important thing that exists is CNCF, Cloud Native Compute Foundations, and it's really, it's driven by major cloud providers like AWS and Google and a lot of different software projects as well, and it's all meant for portability. So it's all meant for being able to move between clouds. But if you think a little bit broader about it, it's not only clouds, because you can apply it to your services. You can run it locally. Kubernetes is one of the kind of main projects inside CNCF. Really, you should go and look it up, because there's so many useful tools in there. that can be used for media, but also other use cases. So independently, if you're running, local, or if you're running a cloud or hybrid, there's a lot of interesting stuff in there. And rightfully, as you said, our focus is more like infrastructure enablement, close to the edge, and that's what we want to do. That's also why we have plugged in a number of other kind of infrastructure features, like GPUs. So you should be able to use GPUs both in the local virtual machine, but also in Kubernetes. VPUs, NetInt. So we have the NetInt cards and MAS in the platform as well. And you can plug all these things together into one ecosystem. So I built a demo just a few weeks back where I took in a stream on a CPU machine, this all being in the Kubernetes cluster. So I have a CPU machine, a VPU machine, and a GPU machine. And I'm balancing stuff between them. And I can also handle resources inside there. So CPU takes the stream in, push it through GPU to do overlays and do a lot of graphics and stuff like that. And then we push it to the VPUs for transcoding and finally out to the CPU for delivery. So again, the ecosystem and the kind of flexibility you get is really, really useful. And I don't know who talked about it. Yeah, auto scaling. Yes, you can auto scale as well. So I need more GPU resources. I need more VPU resources. You can auto scale just that group of machines. And yes, it's all infrastructure. So there's no managed super database or managed the Akamai database or whatever we call it. There's no such thing. We are going for open standards.
Yeah. So something that we came up with in terms of architecture is that we are using Linode Kubernetes clusters on Linode mainly for the user management, the access management, the interfaces, the APIs, the database connectivity, practically everything where customers connect to. So that we are also able to shield that from our own infrastructure completely. So in a typical workload, there is no direct interaction between our infrastructure and any of the customers or the end users. So that is all on Linode and perhaps with some Akamai web application firewall or some other tool in front of that is vendor independent. But then these clusters communicate with our on-prem infrastructure, which we operate, in our case, in Düsseldorf and Frankfurt. And there we have physical machines, large machines with a lot of cores, and they are typically then running K3S, so a single server Kubernetes, so that the developers don't have to care if they are deploying some code on a whole Kubernetes cluster or on a single server. It doesn't matter, so that eases the deployment for the team a bit. And then we can also fire up such K3S server on a VM in Akamai with NetInt cards inside. So that doesn't matter anymore. And also based on a tip of Linode, we're using a technology called KubeSlice that allows us to have one single namespace over all these different nodes and clusters. So the application doesn't even know where it's running, and we have a safe communication between these clusters. So we can, with these tools, we can easily set up a meta cluster that reaches over on-prem and the cloud and different cloud providers with the same namespace. That's pretty convenient. I'm not developing it on it myself because I'm not a developer, but what I see from the team is that is a convenient way to work and to shift loads between these different parts. Some other topic from one of the questions, that is how do we differentiate between today's needs versus infrastructure's value in 3 to 5 years? And I think this is more about if we go on-prem, how do we know that the machines we buy today are still efficient enough in 3 to 5 years? And I have two questions to you two. So I know that Scalestream, your software is very efficient on hardware, so you don't consume too much compute resources. No. Could you first tell us something about that and what that means for the sizing of these physical machines and their lifetime?
Yeah. So especially this is a point that we've taken from the beginning in the development in 2017, performance. And the Origin, for example, on the repackager, we can do 650 channels on one rack unit server, which is quite amazing. For example, at one customer, we replaced 48 servers with just 2. In the end 4, because they had 2 data centers, 2 plus 2, but it doesn't really matter. It's a huge difference. And this is not by using mainly hardware acceleration or stuff like that. It's mainly because the software is developed quite efficiently. So sometimes customers, if we need to replace an existing platform, we often still reuse existing hardware. So we don't really rely on hardware acceleration. Of course, the CPU needs to be not a CPU from 20 years old, of course, but besides that, we don't really rely on specific hardware. So from our point of view, we can definitely reuse hardware, and then going forward, it will be the same. So this the customer that buys the hardware today, it will be valid for the coming 5 to perhaps even 10 years, depending on what will happen with bit rates and codecs and so on. But for that, we put the efficiency in the software and not necessarily rely on hardware.
Okay. Okay, yeah, and the time frame you're looking at is also important. If you look at the cloud providers, the hyperscalers, where you can get reserved instances for 1 or 3 years, that's their time frame that they are looking at. But I think you said when we first discussed this topic that the lifetime of your servers is much longer than 3 years typically. Yeah?
Yes,
So what do you see in practice?
So for example, for video, at the moment it's around 8 years, and it's only because of the technologies changing so much in the codecs, right? Not because of anything else. The servers are still running, but we just started replacing things that are 8, 9 years old. On middleware and other stuff, we have servers that are 10 years old, and we are just replacing them because we think that it's not safe to run them anymore. But they are operational, and we can actually use them if it's needed. So we're pretty efficient on that. The financial amortization is only 3 years, but the actual users between 8 and 10 that we have.
Okay, which gives you a much longer time to distribute
Yes.
the
The only
acquisition
problem
cost.
is hard disks, of course. There it's different. Depends on which batch you get. Sometimes it's 1 year, sometimes it's 5, sometimes it's 3. It really depends. But that's the only part where we constantly change things.
Okay, yeah, interesting. Cool. Another question that I want to cover is how do we make sure that if we aim for high availability, perhaps in cloud or on-prem, we are not doubling our budget? Because that seems to suggest that if we have high ability, we have an A and a B system, so it's twice the amount of money. Is that true? Is that how high availability works? Who wants to answer that?
It depends. So you need to have redundancy, 1 + 1 for sure, or n + 1. Let's call it like that. So it doesn't necessarily be double the space. It can be n + 1 depending on the use case. But often, even in over data centers, there's redundancy, and in the data centers, often it's chosen for redundancy as well. So it's often 1 + 1 in the data center and over the data center again. So it's actually 4 times redundant. It's often still a decision from the customers to go for a fully redundant system. So, and yes, in some way it will double the cost. In cloud, it enables you, of course, to just have the image ready or spin down the system and just operate with 1 + 1. And if needed, you can switch to another data center with a minimal cost. If you go for on-prem, this is definitely something you need to invest in advance. So redundancy is definitely where cloud is in favor, I would say.
I think we have quite a few customers that are doing kind of flexible redundancy as well. So, big event, I spin up 2 more data centers. Take it down 2 hours later.
Correct.
Yeah,
So
but that means you need to have that infrastructure for them to be able to spin it. So
No,
you're
it's-
not
it's-
even 1 + 1, you need to have 1 + 10, right?
I mean, we have 1 + 350,000.
Yeah,
last time I
exactly.
counted,
So that someone
it's,
needs to have this redundancy built in.
Okay, yeah, great. Thank you very much for these contributions. Is there any questions from the audience live here? I know it's always embarrassing and difficult to ask a question in the audience here, but
Way more
yes,
fun.
one question here.
Some years ago, I had a project in Africa, and what I learned is that the OTTs made lines across the Atlantic just to feed the users in Africa. Is this going to happen now in Europe as well, which is much more networked, but less with fiber, still with copper and so.
Africa is very much a different beast because it's not kind of it hasn't been stable all the time when it comes to governments and how and who operates and buys fibers and how you lay fibers across borders if there are borders. So it's really complicated. We had a major breach of one of the subsea cables going from Europe down to South Africa just a few months back. And that had impact. There will be no change. I would say it's the infrastructure around the rest of the world, even like Greenland and other places, is very good. Really, there's like no infrastructure really torn down towards, for example, Russia either anymore. It's just it's just lying there dead, but it's still possible to reactivate it again. And I see no kind of reduction in building new connectivity between different parts of the world. Africa has its challenges when it comes to connectivity because you really need to negotiate with every single government. And it's not like a European thing. We're building a new European pipeline to some place. No, it's not like that. So it is very complicated when it comes to Africa. And I should say India has been a little bit of an island as well for quite a bit, but that has also been improving. I think all cloud providers had kind of an isolated island in India where you have a lot of good connectivity between your different data centers and resources in the country, but you can really get in and out. But that has also improved now. So.
And how does it look in the rural areas?
The one smile.
Yeah.
Germany is a different island.
Yeah. So I really need to look at a map to tell you about a specific case. If we go back to Africa again, they've been very I worked for Ericsson before. Obviously, a lot of mobile networking and cellular networks. They've been building out their cellular infrastructure pretty well, and that has had a lot of benefits. They had mobile pay before we even thought about mobile pay in Europe. So there are a lot of those things, but it also comes with the complexity that everything is built on cellular transmissions. You have links and you have stuff like that, but it's not really high bandwidth links. It's limited. So they are now kind of falling behind a little bit, they were in the forefront like maybe 10 years ago, but now they're kind of falling behind a little bit again.
Okay, one last question. There's two questions we have. Okay, then you signed up first.
From what I heard, there is a lot of distributed computation. Maybe especially in the case of Akamai, I understood that you guys are running software more in the edge part instead of a centralized place, let's say. So my question is, so in a video pipeline, we both have video encoding and packaging. And maybe sometimes it's more convenient to run these two different components in different computing infrastructure. So for example, maybe we want to run encoding in a GPU machine and maybe packaging in a different machine. So my question is about networking. So I wonder if you focus on keeping the pipeline on the same isolation, on the same region, let's say, the same area, or if it's really a negligible cost and you don't care about connecting these two different services together.
So originally, and we talked about it, 1998, Akamai was formed. We didn't have a backbone at all. We relied completely on internet, and we still rely a lot on internet because the internet was built for redundancy, scale. It was built for military use, right? I mean, it was super stable, and it still is. Then we started pushing a lot of data between different sites, countries, and we built what we call our intercity network. And I looked at some numbers, and I talked to some of the telcos, the tier 1 telcos, and we have more capacity in our backbone than the telcos, the tier 1 telcos have. So connectivity-wise, this is how it operates. And I think your question was, how do we kind of differentiate and how do we transfer between cloud and edge? So most of the big edge regions are also connected to this intercity network. So we can do, for example, cache filling, meaning sending a lot of data to different places. This network is also deeply paired with the ISPs, but also to other cloud providers. You know, you can run one workload in, for example, say you're running Media Live, and then you might do something else, packaging maybe in Linode, because you want that edge vicinity. You want very close to the edge processing. I think origination is one very perfect use case. Another one is user-generated content, or when you get content in from many places. That's also very good kind of edge compute use case.
Yeah, and then with the functions you can also separate it. For example, if you want, you can even send one signal to the edge and do even the transcoding locally, and then the packaging and the CDN all in one place for these specific channels, and some other channels you send to another region. And it's more function blocks that you have to look at, and then you can move functions around, like packaging, transcoding, move it to the edge, or so it's quite flexible in that sense.
And we're looking at one of those use cases right now where a customer wants to do like the packaging or ordination in one place, but they want to use the VPU nodes in another place, and then we're going to do that transit between the different places, and that's transparent.
Yeah.
Okay. Last question.
There will be two.
Two, okay. Yeah. That's a trick.
So if we go back a little bit to the on-prem and cloud, there are calculation costs, right? The price of it. So the first question, usually when you have on-prem, you also have engineers, you have on-call team, you have a space where you rent or buy electricity, other services. I understand that you have to calculate everything, and if we take into account clouds where you can use, as Alexander mentioned, reserve instances for saving plan, or use it only when you need, pay-as-you-go model. How do you compare it? And I understand if that will not be cheaper, the cloud business will not exist, right? That's why it's still here. But what is the percentage that you save running on-prem compared to cloud? And the second question, from which size you should consider moving to on-prem? For example, you have 1,000 servers, and in this moment for you that's a sign you have to move to on-prem, or what is the number when you need to consider moving on-prem or stay into the cloud?
I think it depends a bit on the function. Because for some functions it's heavy-duty processes often are in favor on-prem. But for example, if you just want to do VOD streaming, download it from the storage, package it, and stream it. It's egress based. It's a perfect use case for cloud because it scales with egress. You can just deploy it when you need it, upscale or downscale when you need it. Fixed workloads like live ingest and recording to the storage. This is 24/7. Typically, this is done in on-prem, or if it's done in the cloud on specific nodes dedicated for that with specific resources, enablement, and so on. So I think it's function based where it makes most sense, and then it's hard to give a number at which point it makes sense. Especially for VOD or an Origin Shield or something like that, I think cloud or on-prem, there is no real threshold. I think you can mix and match cost-wise. If you go for transcoding, ingest of channels, recording to the storage, probably 50 channels, I would say. Is a bit of a threshold on-prem cloud. roughly.
I would say it depends on the price list of the cloud.
Yeah,
That also.
So I think it's also a very thin one, right? So when we calculate to compare, we take into consideration the labor, as you said, because it's important. We take into consideration the replacement of the hardware. It's a big chunk. Electricity, all of that, right? So it goes in. So we take one service, we know how much we use for that service, and then we compare it to the cloud. What's the difference? So for example, if we had only 10 channels to run them on-prem, we would need the same amount of people like we would need for 1,000 channels. So maybe for 10 channels, I would never consider doing it on-prem, because then you need to operate all of this. But for 1,000, then the difference is big. It becomes bigger because the team is the same. Okay, electricity and the rest, like it's also calculated in the cloud price, right? They don't give it to you for free. The amortization of the hardware is also there for free. So if you already have the team, then it's good. But building a team for a small quantity doesn't make sense.
It's also hard to hire a team. We talked
Yeah.
about that
Yeah.
before.
Yes, we did talk about that.
Developers now are
Yes.
scarce, network engineers
Yeah.
and so forth.
Yeah.
So
Yeah.
that's also a challenge.
Yeah,
To-
data center people is also like something like we have head-ends.
Yeah.
You know how hard it is to find people who understand satellite nowadays? It's like almost like impossible.
Yeah, just two remarks. So there is a huge thread about the company 37 Signals. They did an exodus from AWS, and they published all of their calculations on what would it cost to do everything on-prem, how much the storage cost, how much the service cost. And that's interesting to read in itself. And they also mentioned that they didn't have to hire anybody in addition to the team that they had when they were on cloud only, because they said it's an illusion that you don't need any engineers anymore if you're on the cloud. You still need a lot of people to look into the different services, and sometimes your workload is not triggered because you want to do something, but because there is an update, some version is not supported anymore. So there is some workload coming from the cloud. And the second thing I would like to add is when Deutsche Bahn, the German railroad system, moved towards one of the bigger cloud providers, they were able to reduce their workload on the engineering side, but they quickly noticed that they needed to hire people in the finance department, because now the invoices from AWS in that case were so complicated and so big and so detailed that they didn't know what they were paying for, and they needed additional stuff. That was before there was the whole new industry of FinOps that just looks at cloud providers' invoices and tries to optimize them. So there is a leveling off at a section that you wouldn't expect potentially. So it's not as easy. No?
Yeah.
Great. So we are over time already. Thank you very much for your interest here and for staying here. Thank you for being here. Thank you for sponsoring. So have a great rest of the day without any bombs. Thank you.